So let's go into our next section here on making changes and doing storage administration tasks. As far as making changes go, there's a lot of things that can be done, but just for the pools and the data sets, really the two things that you want to do is with the pools, manage the disk, right? One breaks, you want to know that one broke. You want to be able to replace the disk or add new disk. Offline, we'll look at offline and online of disks. And on data sets, really we want to change settings. So we'll talk about those two things, about making changes or doing administration with the pools and see, messing with the disks or changing settings on the data sets. So let's start off by looking at the disk management tool. So I've run ZPull status -v here, and you can see my pool is made out of this mirror and this mirror. So we can add. So I'm going to do ZPull add to big pool, maybe another mirror of disk 5, disk 5 and disk 6. There we go. ZPull status -v will show us that pool now consists of 3 mirrored pairs. And we can keep adding and adding. Now, if we're doing a different type of RAID too, we can add RAID sets. Give me a second here. Let me tear all this down and we'll start again. Actually, I think I'll show you what I'm doing. I'm just going to do a ZPull destroy of my pool of big pool. Now when I do the df-h, gone. It's all gone. All the data sets are gone. Everything's gone with destroy. Use sparingly. You will see that there's also this argument of -f, which says force. Almost all the commands inside of ZFS have a little bit of protection on you. They'll say things like, oh, well, it looks like you want to add this disk to this pool. It's really part of another pool. Are you sure? And then you can say, yeah, force it. So let's look at creating a pool with RAID sets. So I'm going to say RAID Z of disk 1, disk 2, disk 3, disk 4. Oh, forgot to give it a name. RAID Z. Create a pool called big pool of this RAID set. Now when I do ZPull status -v, you'll see that you've got this RAID set. Now when you add to this pool, you're not going to add in the way that you're kind of thinking you will. So if you ZPull add to big pool now with the RAID set in there, I'm going to say RAID Z of disk, where am I? 5, disk 6, disk 7, and disk 8. Now when this goes together, let me do ZPull status here, -v. And this actually now is 2 separate RAID sets, each that are 3+1. And it's going to stripe across them. Adding to an existing RAID set, you can't do that in ZFS. You can't add to an existing RAID set, but you can add an additional RAID set. So you stripe across these. Now there's also RAID Z2 that allows us to create a big RAID stripe with 2 parity bits, or you can lose 2 disks in that, and RAID Z3, so you can have 3. So I might have taken all 8 of these disks and put them into one RAID set at RAID Z3 and be able to lose 3 disks in the pool. Now, it does stripe across your RAID set, so, getting a balance of performance and redundancy is kind of the trick to storage administration. I guess there probably should still be storage administrators. I don't want to say that they shouldn't be, but, getting that right balance between performance and redundancy is always a key. Best redundancy, lots of mirrors, or just striping. I always say if one disk does 100 IOPS, 2 disks does 200 IOPS, and 3 disks does 300 IOPS. So getting, somebody asked me one time how to get 20K IOPS, and I was like, well, 200 disks? That it depends on the individual disk and how many IOs it does itself. And we'll talk more about that in hybrid storage, but hybrid storage a lot of times makes it so it really doesn't matter what's on the back end. You can have big RAID sets. The other thing, there's a lot of information out there about these RAID sets and how to produce them. If you're doing RAID Z1, don't use more than 4 disks, or kind of ignore all that. Matt Ahrens actually wrote a really nice blog on how RAID is done inside of ZFS. It really has to do with how many transactions it has queued up, how much data it has queued up. It really doesn't have to do with how many disks are in the set. It's like, I have 3 1K transactions that I need to write out. It may, in a RAID Z1, and let's say I had a 6-disk RAID Z1 and I have 3 1K writes to write out, it may actually only use 4 disks for that particular transaction. It may use 6 disks for the next transaction. So it's kind of based on what kind of transaction is kind of in queue and using, space well. So if you want to get a real good judge on that, go to Matt Ahrens' blog off of delphix.com to read that about the different RAID sets. So let's look now at replacing some of these disks. So I think I'm still in DevDSK. Yeah, I have a couple disks left here. I have disk 9 and disk A. Now hot spares are built in. I can say set my hot spare equal to disk 9. I prefer to use the disk and not just have it sit spare, but you can do that. And you just say, ZPull for big pool hot spare equals disk 9. Easy enough. Or we can do this manually where we replace these disks. Let me run ZPull status -v again and see what we've got going. So your state of your pool is either going to be online, and if you have a disk that fails in your pool, this will change over to degraded, and it will actually show you that this disk is offline. If this disk was failed. So if I want to take disk 4 here and replace it with one of my spares, I just do a ZPull replace in the pool, big pool, disk 4 with disk 9. Let me go back to ZPull status -v, and there we see that it's replaced disk 4 with disk 9. Now, that's not usually, you probably don't usually have a bunch of disks sitting around. I'm sitting there and, my redundancies is kind of out of whack. I need to actually physically replace the disk. I do want to show you this here too while we're here. It actually shows you that when it put this disk into the pool, it did what's called resilvered. It doesn't use the word sync or resync just because it's just ever so different than a sync. With typical volumes and resync time, if I have 2 disks and I'm replacing one disk with the other disk, because I have no knowledge of the file system, I have to go through block by block, or the tool utility. I don't have to do this, but the SAN or the RAID or whatever, the JBOD, the RAID card, hardware RAID card, has to go through block by block and copy, right? As take this block and put it on the new disk, and this block and put it on the new disk. Or in this case, it has to read in all that RAID data. It has to read, it would have to read in all of the data and do a resync to that other disk. Well, in this case, you see this happen really, really fast because there was no data on it. It knows, it has knowledge of the fact that there's no data on here, or if there was a little bit of data, let's say I had a, 200K worth of data written, it'll take and it will write 200K. It knows how much needs to be done. It doesn't have to do that block by block synchronization. Now, let's talk a little bit about offline. Let's say disk 8 fails. Now, what I can do also, and this is more likely what you'll end up doing, ZPull offline in the pool, big pool, disk 8. So back to ZPull status, what you'll see here, disk 8 is offline. With hot swap drives, we can offline, we know disk 8 is broken, we need to replace it. So what we do is we offline the disk, pull the disk out of the chassis, put in a new drive, and then just go ZPull online that disk. So we physically made the modifications while the disk was offline. ZFS knew not to write to that drive for a second or two while we're physically, or a minute or an hour, or depending on where we're at, right? But then we can do the command ZPull online that disk, and it'll come back online. And it might be a new physical disk. It might have a different user ID, but we know that it's in that same position. And with Solaris, it's going to be, C1, T1, or CTDS something. It's going to have a device name associated with that. I should do a little video on that too. But so now it's back online. We're up and ready to go. So those are the primary administrative commands that you do with ZPulls. Now let's look at administration for data sets. So I'm going to have to just create some here since I destroyed mine in the pool. I'm going to go big pool data. Now you also can create data sets inside of data sets. So there's this property of inheritance. We can decide whether or not, let's say we have a ZPull data and we want to create one for a user named Jacob in that data set. You can decide things like whether or not the settings that are done on big pool data, if those will be inherited by any new data set underneath it. By default, inheritance is turned on. My son's actually named Jacob, and I actually have twin boys named Jacob and Matthew. They're 13 years old. DF-H. We'll run that here. So I have, now I have my bigger pool. All of the space is shared with all of these data sets. Now, one of the settings probably that gets set the most is this idea of quota. And I like to use my twin 13-year-olds as an example. I think twin 13-year-old boys really genetically don't have the ability to share. They don't know how to share. That's just a joke, but yeah, it's true too. My son, Jacob, actually is the kind of kid so let's say I had a big bowl of candy and I said, here, you guys share this. My son, Jacob, is the kind of kid that would just take the whole bowl. And he would hide it. He would put it away somewhere. So if you're in a situation where you're, here you guys share, not going to happen. Jacob's going to take everything. So I'll show you one of the settings that we can set. ZFS set quota equal 100 meg to big pool /data/Jacob. And this would be the equivalent of taking, a portion of my big bowl of candy and saying, here, Jacob, this is what you can have. Now, that doesn't mean that it doesn't mean that I don't still have candy laying around. It means that for now I've just given him 100 meg worth, and limited to that. Now, if I need to tweak that up, I can turn this up at any time. Let's say he has a write in flight. I want to turn this up to 200 meg. Bam, done. It's there immediately. It's ready to go. So this is a logical setting. It's not a physical setting. I don't know if anybody out there is old enough to have, had to partition disks and, determine, how much space you need for export home, trouble, changing the size of file systems was always very difficult. This is one command, done. Now, I like to use my twins because my other twin is the exact opposite. He's the kind of kid that I'll say, here's a big bowl of candy. Would you like some? And he'd say, no, Mom, thanks. I don't want any candy right now. So, and then he'll come back to me a couple days later and go, hey, Mom, what happened to that candy? And I'll go, oh, your brother ate it all. For him, I can actually, there's a setting, a ZFS setting. I wish there was a ZFS world setting for this, but there's a ZFS setting for him. There's reservation, and I can set this to whatever value I want. I'm going to set it to 100 meg on big pool /data/Matthew. Now, when we do the df-h here, you'll see what happened. Now, Matthew's not limited at all to how much space he uses. If everything else in the pool uses all this space, he won't really get some. But what I've done is I've taken 100 meg worth of storage and I've put it aside. I've reserved it for him in the future when he's like, hey, Mom, where's the candy? Right? So I have that. Now, you'll see the 100 meg has been taken out of everybody else's available space. So that's quota and reservation. Now, the ZFS, there are a lot of settings. I'm going to do a ZFS get all on big pool data. Wow. Yeah, lots of things here. So go back to the top of our list. Here in get all, it shows us the name of the data set, the name of the property, and what its currently set value is. And it also shows us things like, was this set by default or did somebody set it? I don't have a reservation on this one. I should have done. Here, let me do Jacob so you can see that the reservation was set. So we see that the quota was set to 200 meg and the person who did it was local. So it was done by somebody. We also see what the mount point is. So all of these different things here, almost all of these things you can change. They're all variables that can be set. Here's just, 200 meg, mounted, yes, compression ratio, what the current compression ratio is. Compression is turned on by default. Available space, things that are referenced other places, the date and time of creation. Now, after we get down underneath mount point, these things start to get really interesting. Share NFS. I can just say set share NFS equals on, and share NFS is turned on. Compression is turned off right now, so I can turn compression on. There's a number of different compression algorithms that you can use, so you can not only turn that on, but set it to a certain value. Checksumming is always turned on by default, and we'll talk more about that later. Whether or not we update access time every time something happens to the file, that's something that typically you want to turn off if you have virtual machines, because inside the virtual machine something else is keeping track of access time, so that's a double hop that you get there. Whether or not you can execute, set UID, read only, whether this is being used for zones. We have the snap directory. Now, snap directory by default is hidden. We'll talk about that more a little bit later. Some things on ACLs gives you some hints that we can do things like have ACLs on this. The version of ZFS that we're using, case sensitivity, share SMB. So we have, share CIFS. The Solaris has by default an in kernel CIFS. So we can turn that on. There's a couple more commands that you have to do to get share SMB turned on. Like to put a plug in here for my class, as I actually teach a sharing class where we go through all the different types of sharing in detail. Virus scan has the ability to send data to a virus scanner before it gets written. Primary cache and secondary cache. We'll talk a lot about this later, but ZFS likes to cache everything. It likes to cache as much as it can in memory. There's something called the ARC, the Adaptive Replacement Cache. And I'll talk a lot more about this in another. I have a whole module on ARC. And ZPull, but we can decide what gets cached. Like if you have, hundreds of little files, you may just want to cache metadata, and not the file data itself. Or you may want to cache all or cache nothing. You may want to say primary cache equals none, and let's make sure everything gets cached into secondary cache. So all, meta, or none are our choices here. We also have, how much of the space is used by snapshot, used by children. And there's this log bias. This log bias actually is put in for basically for databases. We have the ability to set this for latency or throughput. So when ZFS first came out, we did a lot of databases with it, and we would take tables and logs and make those data sets latency centric, and then we take the big table spaces and make them throughput centric. So we could do that, per data set. I'm not going to talk about dedupe at all. I'm just going to say use with advisement. Take advice on whether or not to use dedupe. Compression ratio written, how much space is being used, all of these things, well, some of these things can't be set. I can't set how much, is, being used by snapshots. Those are things that don't have the default next to them. Those are things that are just are, right? They either are or not, especially like version. I can't manually change my version number. So things that are just information about the data set can't be changed. So lots of different things that can be changed on a per data set basis to make it so you can use each data set for something different. I can take one data set, share it SMB. I can take another data set, share it NFS.